Okay, so it's really important in this homework that you read particularly the IEEE source about solar energy, because it discusses a lot of the nuance in whether solar energy is carbon neutral or ethically sourced. And it's a very nice balanced article. So specific data about how much carbon is emitted in the production of solar panels, it's difficult to find, partly because the technology is constantly evolving. But I did some extrapolation, and it takes about 720 grams of carbon to produce a panel, and I put panel here in quotes because it's not actually a single panel, but to produce a panel that's capable of outputting 1 kilowatt per year. So how many grams are produced to create a system capable of producing this 1100 kilowatts per year? And so that just means we want to get from 1 kilowatt per year to 1100 kilowatts per year. This is essentially a ratio. So 720 to 1, and we want our final ratio to be 11,000. So we're just going to multiply both sides by 11,000. And we get 7,900. Sorry, 7,920,000. And we need to adjust this for significant figures. So our final answer is going to be 7,900,000 grams. And so it wants to know how many kilograms this is. So I'm just going to set up my train tracks. Grams, and then we have 1,000 grams per kilogram. This allows us to cancel out our grams, and we get 7,900 kilograms of carbon produced in order to create a system that will meet our energy needs. So for our solar panels, as soon as they're made, we've produced 7,900 kilograms of CO2. But they haven't produced any more after year 1, 5, 20, or really any number of years. Okay, so we figured out the energy for our solar system, or the carbon emissions for our solar system. Now we need to figure it out for our full grid system so that we can make an adequate comparison. So the industry averaged 0.99 pounds of CO2 emissions per kilowatt. And I want to know what that means for 11,000 kilowatt hours. So for every 1 kilowatt hour, they produce 0.99 pounds. But we want our final answer in grams. So I need to figure out what the conversion rate is for grams and pounds. And it turns out that 400 and not 450, sorry. It turns out that 454 grams are in 1 pound. So we're going to multiply all of this across the top. And we're going to get, let me erase and make some room down here. We're going to get 4,944,000 grams are produced. I didn't properly cancel everything out so that I could see what my final unit was. Okay, and so this is roughly equivalent to 4.9 million grams. And we want to figure out how many kilograms this is. For that, I actually need to write out my 4.9 million grams. We have 1,000 grams per kilogram. Cancel my units. And I get 4,900 kilograms of CO2 per 11,000 kilowatt hours, which is essentially a year's worth of electricity. And so if we move over here, that's exactly what we're going to see is after year 0, they have produced 0 carbon emissions. But after year 1, we've produced 4,900 kilograms. After year 5, it's 4,900 times 5, which is 25,000 kilograms. After year 20, it is 4,900 times 20, which is 98,000 kilograms. And after X years, we have produced 4,900 times X kilograms of carbon emissions on the full grid model. Okay, so here I've already combined the charts for us so that we have an easier time of doing things, although clearly I didn't round correctly here. So that's actually 25,000. And I did some bad math here. So this is actually 98,000. I shouldn't have done these charts ahead of time. Okay. So after 1 year, which system has produced the most emissions? So after 1 year, we can see that solar is still a problem. And after 5 years, solar is no longer a problem. It is the problem with the grid. And since solar stays static, we know that after 20 years, it's still going to be a problem with the grid. So what we're seeing here is that it's a bit of a misnomer to claim that solar produces carbon too. It does. It just doesn't produce it at the rate that our full grid does. So we're going to complete our chart here and then graph everything. So years is still going to be an interval of 1. Our kilograms of CO2 emissions will go over here, and it gets up to 98,000, which is almost 100,000. So that's what we'll use. And I'm just going to say 100,000 represented with the K there. And that means our interval, if we divide that by 20, is 5 Okay, so we'll label our graph. Okay, so our first year, or for our full solar energy, it's 7,900 straight across the board. So this here is 5, this is 10. 79 is going to be closer to 5 than it is, no, closer to 10 than it is to 5. So right about there. Okay. And we need to label that. And then for our electric grid, our first point is going to be 0, 0. Our second one is going to be 1, 4,800. So just below this 5,000 line. Our third line is going to be 5, 2,500. So right there. 20, 98,000. So right about here. And I'll go ahead and label my graph while I'm at it. Okay. So about when do solar panels become carbon neutral? Carbon neutral is a weird word in this place, I should note. Sometimes carbon neutral means that they store as much carbon as they do. I'm saying in this case, carbon neutral means that they have produced as much energy, or they have saved as much carbon going into the air as they have cost. So that means that they become carbon neutral when they cross this line with the grid right here, which is at about 1.5 years. And does this exceed their expected lifetime? No. The reason this question is important is if they were to become carbon neutral at 30 years, then we couldn't really say that they were claiming carbon, because we can't expect our solar panels to last more than about 30 years. And that is it.